we will look at two ways to solve quadratic equations. The first way is by graphing. You can simply graph the quadratic equation and then estimate the solution looking at your graph. Now, the solutions of the quadratic equation are called the roots of the equation. One method for finding the roots of the quadratic equation is to find the zeros. The zeros are the x-intercepts. So basically what this paragraph means is the x-intercepts, same thing as the zeros, which is the same thing as the roots. So I want to see where my curve crosses the x-axis. That's what I'm doing whenever I'm solving these quadratic equations. Solutions. When I graph, there's three different options that I could have. I could have one solution, and that's when my parabola comes down and hits my graph in exactly one spot, my x-axis, or when it goes up and hits my x-axis in exactly one spot. You might have exactly one solution. You could also have two solutions where your parabola hits your x-axis in exactly two places. Okay, and that can be for either direction. Or you could have no solutions, which is fine. No real solutions. Basically, my curve never cuts through my x-axis. Nothing wrong with that. Now, since using the graph, you just have to estimate the best answer, so we will not be solving by graphing a whole lot. The next method we're going to take a look at is factoring. Now, the zero product property, you already know this. It just might not have been as formally stated to you. Basically, what it says is if A times B equals 0, then either both A and B have to be 0 in order for that statement to be true, or just one of them have to be 0. If one of them is 0, I don't care about what anything else is, and the whole function is 0. So if I gave you something like x plus 5 times x minus 7 equals 0, then what we do is we set each binomial equal to 0 and solve. So therefore, if x is negative 5 or 7, or both negative 5 and 7, then that would make that statement be true. So now we're just going to practice solving some quadratic equations by factoring. Take a minute, try both A and B. For the first one, I can pull out my GCF. Well, I set both of these equal to 0. Pull out my GCF. So that means x equals 0, x minus 6 equals 0, so x equals 6. So my two answers, so these are my two answers, and if I want to write them or think about them as the x-intercepts, it's going to be 0, 0, and 6, 0. Now in part B, I would first want to move the 15 over. Then I want to factor, and it factors into 2x minus 3, x plus 5. Then set each of these binomials equal to 0. So I got x equals 3/2 and x equals negative 5. If I want to write them as x-intercepts, then those would be the 2 points where the curve crosses my x-axis. Take a minute, solve this one. Okay, this thing factors into x minus 8 equals 0. So I get x equals 8 in both cases. Now I wouldn't write the same answer twice, so I would just kind of summarize and say x equals 8, or the x-intercept is 8, 0. This is considered to be a double root. So this is where my parabola hits my x-intercept in exactly one spot. Let's try the next one. This is actually an SAT problem. What is the positive solution of the equation 3x squared minus 3x minus 60 equals 0? First, I would pull out my GCF, which is 3. Then I would factor. Then set each of those factored terms to be equal to 0. So I get two answers, x equals 5 and x equals negative 4. Now, since it only wants the positive solution of the equation, my answer has to be C. And the last example, write a quadratic equation with 1/2 and negative 5 as its roots. Write the equation in the form ax squared plus bx plus c equals 0, where a, b, and c are integers. Basically, we're going to go backwards now. I give you that x equals 1/2 and x equals negative 5. So think about how we went from the binomials to the solution. We always took the opposite sign. So think about it's x minus 1/2 and x plus 5. Now all I'm going to do is FOIL my binomials together. So I end up with x squared plus 5x minus 1/2 x minus 5/2. So then I get x squared plus, I get 4.5, which is 9/2, x minus 5/2. Now the problem says I want all of those a, b, and c to be integers. So what I want to do is I want to multiply each side by 2 to get rid of the 2 in the denominator. So I'm going to multiply, and this thing still equals 0. I'm going to multiply the whole thing through by 2. So then I end up with 2x squared plus 9x minus 5 equals 0. Okay. Now there is another way to do this, and that's back where you can rewrite x minus 1/2 a little bit differently. I don't want to give anything away. See if you can figure out a different way to rewrite x minus 1/2 and still get the same solution.